Hello everyone, today we are going to understand binary search. What is binary search? Its needs, its implementation, and then we will calculate its time complexity in this video. So what is the general definition of binary search? Binary search is a searching algorithm that operates on a sorted array that repeatedly dividing it into halves to find a target value or optimal answer in logarithmic time, which is a big O of log n, which is a pretty good time complexity. So what actually the binary search is? It is a simple algorithm to search or find a target element in a sorted array. So the condition of binary search is that the array should be in sorted order. So it can be in ascending or descending order, but most of the time we are dealing with ascending order. Means elements in an array is arranged from smaller numbers then goes to a larger number, as we can see here. So so basically what is the need of it? When we try to find a target element in an array, what is the first thing or first approach that comes to our mind is that we should use a linear search. Like we will take an pointer and we will apply some for loop or any other loop on it, and we will iterate through each element in there. Like we will see this element is our target element, this element is our target element, this element is our target element, and through all we will see our target element is. So suppose we have to find 12. So we have to search each and every element in an array in linear search. So in the worst case, what if the target element is not present in this array? Or what if the target element is the last index? So what we have to do, we have to search each and every element in the array. So I think it is not the optimal approach. So here comes our binary search. It is more optimal than the linear search. So in the binary search, what happens is that we we have taken two pointers, that is start and end. The start pointer is starts from the zero index, and the end pointer is on last index. So what we have to do that is we have to calculate the mid of this two index. So here we have to do 0 plus 5, 0 plus 5 by 2. We got mid as 5. So what we have to do next is that if our target element, suppose we our target element is 12, so it is, as we see, it is greater than mid. So what we have to do, we have to shift our right, that is mid plus 1. Now our array is separated into halves, means our searching space is get reduced. Now our searching space is this. So like this we will search our target element. Now again we have to iterate on this searching space. So we have to iterate on this searching space. What we will calculate again our mid. What our mid is 3 plus 5 upon 2, that is 4, that is 4 index. So our new mid is this. So now we will check if mid is our target element. So yes, mid is the target element. So we will return mid, that it is the target element. I will explain this again during the explanation during the implementation of the code. Now we will implement our binary search algorithm in Java. You can implement it any language like Python, C++, or any other language. I'm more comfortable with Java language, so I am implementing it with it. So we are implementing in Java. I have taken one array, as you can see, and and a target element that we have to find a a in this array, and print statement. So now we have to write a binary search function for this array. We are calling this binary search function and passing array and target as an argument. Now we will implement our binary search function here. We will take array as an parameter and target as a parameter. Now as we can see, we have to take two pointers, that is a start pointer which we will start from 0 index, as we can see here, which we will start from 0 index, and we will take another pointer and which we will start from the last index of an array. We will take one variable for storing length of an array. Now we will take while loop for iterating through our array. So the condition should be the start is less than and equal to end. Why this less than sign? Because what if the what if we have to find 6, which is just beside the mid element. So if we have to find 6, the start and end should be at the same point, pointing to the same element. And when we will calculate the mid of this element, this also points to this target element. So if we don't apply less than and equals to sign, this condition will not match, and we will get the loop will be break. So we will apply start is less than and equal to condition. Now what we have to do inside this mid is that first we have to find the mid. Why we are writing inside the while loop? Because for each iteration, like for each iteration, we have we are finding the mid. For each iteration, like for the first iteration we find 2 as the mid, then for the next second iteration we find mid as 4, which is our target element. So we are writing mid inside this while loop. So we will calculate mid by this formula. Now we have to check if ARR of mid is equals to our target element. If if this is the condition, then we will return the mid. Else if ARR of mid is less than target, means target is greater than the mid element, as we see in our explanation that if target is greater than mid, in the first situation the mid was 5, so our target element is big, of course, because bigger than the mid element. So what we will do, we will do mid plus 1, and we will do start is equals to mid plus 1, so the pointer comes to this position. or else we will do or else we will do and equals to mid minus 1. Suppose we have to find 4 as our target element. So what actually we have to do? This is the start, this is the end. Our target is less than the mid. So mid, we'll do end is equals to mid minus 1. So this will target to this element. And when this both comes to at this place and we will calculate mid again, we will get our target element. So that's why we write it. This is all the code, and what if the target element is not present in our array? We will just return minus 1. Let's check if our code is right or not. As you can see, our target element is at index 3. So 0, 1, 2, 3. 8 is on 3 position. Let's try to give some different target number like 5, which is on index 1. So this is the right solution. Now let's try to understand or calculate the time complexity of our binary search. So before calculating the time complexity of binary search, we have to understand why the time complexity of binary search is better than the time complexity of linear search, and why we are choosing binary search over linear search. As we can see, we have to iterate through all the elements in the linear search. Its time complexity is big O of n, because we are iterating through each element through an array, and the worst case condition could be the element uh, the element could be in the last index of an array, or it is not present in array. So worst case time complexity is big O of n. So in the binary search, what we are doing, we are reducing this search space of an array into halves. Means we are reducing this search space. So what if the input size of an array is n? First, if the input size of an array is n, we are reducing the array into halves. So it will become n by 2. Likewise, it will become n by 4 until it becomes 1. Means, as you can see, as you can see, 2, 4, 8. So pattern is like it is n by 2 square, by 2 square, n by 2 cube. So like this, till in which condition we will get 1. 1 means we found our target element. So likewise 2 to the power k. So what so condition will be n upon 2 to the power k is equals to 1. This is the condition where will find our target element. So here we have to apply log condition because we want k because we want the value of k. So if you know log, the log 2 becomes 1 and this k will comes here. So log 2 becomes 1 and k will lie here, and this is the logarithmic complexity. So as we have calculated the time complexity of binary search, which is big O of n, big O of log n. So it is a pretty good time complexity. And how we made a conclusion that k is equals to log n is our time complexity for our binary search algorithm. So as we can see this pattern, that we are dividing the input array into two halves. So this pattern will come, and the value of k will represent when we are going to get the value 1, and this value represent when we are going to find the target element in our array. So basically the value of k is useful to find the target element in an array. So log of n is actually the time complexity of our binary search algorithm. So as we have seen in this video, we understood what is binary search, what is the need of this. We will see the code implementation of binary search, and then we have calculated the time complexity of binary search, which is a big O of log n. So thanks for watching.